start our today's session. So this is going to be the third lecture on kinematics. Again, this is unit 1. And what is required to understand here is that whatever we are going to learn in these units, like unit 1 and the subsequent units, everything will be connected. It's not like that the topic here we're going to learn is different from others which we're going to use in the next chapter, next unit. So whatever we're going to learn, you need to make sure that you learn and remember everything. So far we have like knowledge about distance displacement, speed, velocity. There is one more thing that we need to understand in today's session, and then we move towards the equations of kinematics. So that thing here we have is something we call acceleration. Define acceleration as rate of change of velocity, like with which rate the velocity changes there must be some acceleration, and there are two possibilities that velocity might be increasing, velocity might be decreasing. We're going to talk about both the cases. So rate of change of velocity with respect to time, that is something we call acceleration. So it is a vector quantity again, and whatever principles or whatever laws which we are using for vectors we'll be using for acceleration as well. So it is a vector quantity. Also, if I talk about its unit, let's try to find out what its unit is going to be. So acceleration is represented by a vector. It is nothing but rate of change of velocity. So rate of change of velocity is something that we represent by this delta v by delta t. So what is the meaning of these terms? Let us try to figure it out. So delta v is something which is representing change in velocity. Change in velocity of the body. Whereas if we talk about delta t, it is something in what time the velocity change takes place. So we know the unit of velocity is it is meters per second, and again it should be divided by time. So unit of acceleration is going to be meters per second square, or we can also represent it as ms to the power minus 2. Let me just give you an example to make you understand that what exactly this acceleration is. Suppose there's a car, and initially it was traveling with some velocity. It is traveling with, I assume, 20 meters per second of velocity. Within 10 seconds, what I saw is its velocity changes to 60 meters per second. Although that is a huge difference, but just a case, just a scenario. So in this particular case, how we are supposed to find the acceleration of the body? So acceleration is defined as it is nothing but rate of change of velocity by time. So whenever we are writing change in velocity, we always need to write final velocity minus initial velocity. That is important. So it is going to be somewhat, I can say, 60 minus 20 over 10. So acceleration will be what? 40 by 10, that is 4 meters per second square. Now, what is it actually signifying? What this 4 meters per second square representing? So it actually represents that the velocity of the car will be increasing. Velocity of the car will be increasing with 4 meters per second every second. This is what it means. This is what we mean by acceleration. So this is a very basic thing, and generally you can relate it with the simple phenomena. So you must have, I guess, ride sometimes bicycle, motorcycle, and even car. So what does that accelerator do? What does that accelerator do? It simply increases the speed. It simply, we can say, it increases the speed with the time continuously. So when we accelerate, it means that we are increasing the speed with respect to time. So with respect to time, speeds actually increases. That is something which help us to explain what acceleration is. So we can also represent acceleration through this particular relation. That acceleration is going to be v minus u by t. Now what this v is representing final velocity. What this u is representing initial velocity. That is, you can understand there. So this will give us, or you can say this is a simple formula for calculating acceleration, and this is what it is. One more thing. As we know, it is going to be a vector quantity. So how we are supposed to write the direction? That is the next point that should come to your mind. So direction of acceleration is something always in the direction, always in the direction of change in velocity. Always in the direction of change in velocity. Now let me give you an example. You'll automatically understand it, what it is. So in order to understand it, I suppose that there was a car. This car is traveling on this level road. Initially, the speed of the car was u. Later on, I figured it out that velocity changes to some value v. So motion, during that motion of the car, it must have covered some distance.
Mm-hmm.
So that distance is going to be this. Simply. Also, I can assume that initially the time was supposed to be 0, and at this particular point, times become some t dash. So how we are supposed to calculate the acceleration? So acceleration is simply represented by that a is going to be v minus u by t. You can also calculate this distance, that how much distance this particular vehicle has covered during the given time. Now, the important part is displacement. So if you look at the important part is direction. So if you look at the direction of velocities initially and finally, what it is supposed to be? The initial velocity is supposed to be in x-axis. So I can represent it by I cap. Similarly, the velocity final of the vehicle is also in x-axis. So again, it is supposed to be I cap. So I can simply say that the acceleration is also going to be in x-axis. So it is represented by I cap. This is what we need to understand. This is a vector quantity. Again, remember, a vector quantity is something which has both magnitude as well as direction. So suppose in the last case, we got acceleration as 4 meters per second square. So how we are going to write it? We are going to write it. It is going to be 4 meters per second square I cap. So 4 meters per second, or the 4 is representing the magnitude of acceleration, whereas I is representing what? The direction.
Direction.
That is also we need to understand. Whenever we are writing it according to this. So does this make sense?
Yeah.
All right. So let's move to the equations of motion. And before that, let me just give you a little idea about what kinematics is. Kinematics is the branch of physics which deals with the motion of the body. It is a branch of physics which deals with the motion of the body without knowing its cause. Without knowing its cause. What does it mean? It means that we are going to talk about all the aspects of the motion, but we won't care that why this motion is taking place. That is what kinematics is all about. So in
Okay.
order to represent the motion of any body, any particle, it can be takes place in two different ways. First, it can take place in one dimension. Second, it can take place in two dimensions. So in the unit, we are going to cover both aspects of motion. When we are talking about the two dimension motion along two dimensions, so how it can take place? Either motion can take place along x-axis. Similarly, motion can also takes place along y-axis. Also, if I talk about two-dimensional motion, it is going to be something which takes place simultaneously along x-axis as well as y-axis. So this is going to be completely new thing for you. But understanding motion along one dimension will ultimately leads us to understand motion along two dimension. So understanding motion along two dimension is nothing but the combination of motion along y-axis as well as x-axis. So
Okay.
in order to represent the motion along x-axis as well as y-axis, there are certain equations that we need to understand first. And those equations are called equations of motion. So in order to understand and we can say explain motion, we have different equations of motion. We have what? Different equations of motion. Now, if we just think practically, so as far as this unit is concerned, we have covered the following physical quantities so far. And these physical quantities are distance. I'm only going to talk about vector quantities. So we talked about displacement, we talked about velocity. Now we talked about acceleration. So apart from these physical quantities, there is one more quantity that is required to understand motion, and that is time. Because without time, we cannot relate motion. So time is the most important part. So these four physical quantities will somehow we will relate and try to explain what equations of motion are. Now, how do we represent them? That is again an important aspect. So as far as I have seen in AP Physics curriculum, the displacement is something which is represented by x minus x naught. I'll make you understand what this x and x naught is, but you can also represent it by s. S is going to be displacement. Then velocity is something which is represented by v vector. Acceleration is something which is represented by a vector, and time is something which is represented by small t. Never represent time by capital T because capital T stands for temperature. It is a symbol of temperature.
Okay.
So, using these physical quantities, we have created three equations of motion. So, I would write there are three equations of motion which relate all the physical quantities. Like how? Let us understand. So, these are going to be first V minus U is equals to a t. This is the first equation of motion. Second, x minus x naught is equals to ut plus half a t square. Third, v square minus u square is equals to 2a multiplied by x minus x naught. So these are the three physical equations. These are the three equations of motion which help us to relate the motion of any body traveling with whatever speed, assuming there are changes. So this is how we can relate them. Now let us try to understand how these physical quantities are actually used to represent the motion. So I assume that there was a particle or there was a car moving along this horizontal road, and initial point of the journey of this car is supposed to be origin. I assume origin because whenever we are actually representing the position of the position of the particle, we always need a reference point, and that reference point is something we can assume here. It is origin. So I assume that this is going to be the reference point, and here the displacement is supposed to be zero because at origin, what is the coordinate of x-axis? It is zero, right?
Yeah.
So I assume that initially the body was at this point, the car was at this point. So this is the initial position of the car. So I assume that it has some coordinate x is equals to x naught. First of all, I will make you understand the motion along x-axis only. That is something which is also called as translatory motion. Let me write it here. So motion along x-axis is something which is also known as translatory motion. Apart from this, it is also known as rectilinear motion. So whenever particle is moving along x-axis, we can or the examiner can use certain terms to represent that motion. So whatever type of motion we are talking about, equations of motion will remains this. These are the only equations of motion which we are going to use throughout this kinematics unit. Not only in this unit, but also in the upcoming units, we are going to use these equations. So let's get back to this situation. So I assume that the particle or the body was initially at this position and I marked its position as x is equals to x naught. After some time, I observed that its position changes and its position changed to, I would say, x is equals to some x. So this is the final position. Initially, the car was moving with some initial speed u, and finally its velocity changes to v. So just tell me what is going to be the displacement for this journey, for this motion.
Um, x minus x, what's it called? X0, x dot.
This is the final position with
Yeah.
respect to the origin. This is the initial position with respect to the origin. So whenever we are marking the displacement, it is nothing but distance between initial and final position. So what it is going to be? X, and this is x naught. So it
Or
is going to
not.
be x minus x naught.
Yeah.
So this is how displacement we are going to use x minus x naught. Then here in these equations, initial velocity is something which is represented by u. Always remember, final velocity is something which is represented by v. Also, acceleration is something which is represented by a. So whenever we are going to solve any problem based upon these things, we need to have at least three of the given quantities to find remaining quantity. So we can also represent the same situation graphically. Let me give you an idea. So in this particular case, we are going to have three types of graphs. There are going to be three types of graphs to represent the motion. Now, what these graphs can be. When you'll be having the assignment from the school based upon these things, I would like to discuss those questions, irrespective of those questions which I used to teach, because there is a huge gap in representing the physical quantities. So I don't want to confuse you by using different quantities, different symbols. So we're going to discuss those questions only. That will definitely help you a lot. So three
Okay.
kind of graphs are there. First is it is going to be displacement time graph. So we are going to observe that how displacement of the body changes with respect to time. Second, we are going to have velocity time graph. So we are going to observe how velocity of the body changes with respect to time. Last but not the least, we are going to have acceleration time graphs also. So acceleration time graph is something which is very common and it is the only one we have here. There is no variation in such graphs. One more thing that we need to understand here, that those equations of motion which we saw in the previous page are only applicable when acceleration is constant. These equations of motion are only applicable when acceleration of the body is supposed to be constant. Now, how we are actually going to use it and how we are actually going to identify it that the motion possessed by the body is something which has constant acceleration. This is the very key point. So before understanding this particular factor, there are two more physical quantities that we need to understand. And these physical quantities are, first we call instantaneous velocity. Now what this instantaneous velocity is? Instantaneous velocity is something which is used to represent velocity of the body at any particular instant. Velocity of the body at any given instant. Now, what does it mean exactly? Let's go back to the figure we drawed in the previous page. So, at some initial position, I assume the body has the velocity u, and at some final position, we assume the body has some velocity v. But what about at any random position in between that? What its velocity is going to be? I assume it's v dash. So this v dash is something which we can refer as instantaneous velocity. So, in some questions, in some problems, it might be asked that what this instantaneous velocity is, or I can say, like, suppose the particle is traveling for 10 seconds, and the examiner asks us, what is the velocity of the body at third second, specifically third second. So that is an instant, that is a specific instant, third second. So examiner may ask at that particular point of time. So that velocity at third instant, third second is going to be instantaneous velocity. Now, how we are supposed to find that instantaneous velocity? V instantaneous is nothing but dx by dt. Now, what this whole thing means. Here, x is displacement, and whenever we see d by dt with any physical quantity, it simply means that instantaneous velocity is nothing but rate of change of position of the body. In easy words, I would say that by what rate the position of the body is changing, it is going to give us the instantaneous velocity. So just tell me, do you have any idea of calculus? Are you doing it right now or have you done it
Yeah,
before?
I'm doing it right now.
So what you have done so far in calculus?
We did Riemann sums, uh, limits, continuity with limits. Uh,
Have you started derivatives?
no, that's our next topic.
Okay. So this d by dt is something which is representing the derivative. For example, if we have the displacement equation, so that d by dt is something representing that we have to differentiate the equation of displacement in order to get the velocity. Just 1 minute, I'll be right back.
Okay.
Or yes, I am back. So instantaneous velocity is something which is representing rate of change of displacement or the position of the body. Let us try to understand it, what it is. So suppose that the displacement of a body is given by 3t square plus 5t plus 6. Have you seen such equations before?
Um, Quadratic.
Yeah, it is a quadratic equation.
Hmm.
So this quadratic equation is of displacement, and this equation is a function of time. So whenever we see that the position is a function of time, whenever position is a function of time, if we differentiate this equation, if we differentiate such equations, if we differentiate such equations, we will have velocity. Now, how we are going to differentiate it? Let us try to understand it. Also, we are going to learn the same thing in calculus as well. Whenever you are going to learn about derivatives. So here we have x is equals to 3t square plus 5t plus 6, I assume. So how we are going to differentiate it? First, we are going to write that with respect to what we have to differentiate it exactly. So differentiate it with respect to. So whenever we are differentiating a particular equation, we are going to differentiate it with respect to the variable present in it. So in this equation of displacement, what is the variable? What can you say about the variable?
Uh, T, which is time.
Exactly. So whenever we are going to differentiate it, we are going to differentiate an equation with respect to the variable, and here the variable is going to be time. So we'll simply write time here. So I can say that how we are going to differentiate it, like how do we actually represent it? That is the next question. We write d by dt, or we multiply the whole equation by d by dt. Let's simplify it. So I can say it is going to be dx by dt, which is equals to d by dt of 3t square plus 5t plus 6.
Hmm.
Let us simplify it. So to the next page, I guess that is going to be much better.
Yeah.
So dx by dt is something which is velocity. So I can write here velocity also. So the equation was 3t square. So how am I supposed to write d by dt of 3t square? Now this d by dt is going to be multiplied by all the terms present in this equation. That is 5t as well as 6. This is something which you are doing for the very first time. So that's why I'm writing the whole equation this way, like elaborating each and every step. But once you are comfortable with the phenomena, once you are comfortable with this mathematical operation, differentiation is something which is very easy. So I
Okay.
can write V is going to be now in this term 3t square. Just tell me what this 3 is. How we can like exactly categorize this 3?
Uh, I guess would be like logically, if you think about it, or what?
Yeah, logically, what do you call it?
Constant.
Yeah, constant. So whatever constants are there in a given term, they won't participate in differentiation. So they simply comes out of it. So 3 will come out of it, and we can write d by dt of t square.
Okay.
Similarly, here 5 is also going to be come out of it. So inside we are left with t only. Here 6 will also come out of it. So inside we have nothing. So if there is nothing, can I write 1?
Yeah.
If it is 1, Can I write 1 as t to the power 0?
Yeah.
Any variable raised to the power 0 is always 1. So in place of
Yeah.
this 1, I'm going to write t to the power 0. Now, what's the process? How we're going to actually differentiate it? Let me just give you a small idea about it. Suppose we have x to the power n. So whenever we are going to differentiate this equation, it simply says power, whatever power this variable has, it will come in front and 1 will be subtracted from the power. This is something which we also called chain rule. You're going to learn the same in calculus as well.
Okay.
So let us apply the same thing in order to find the velocity. So velocity is going to be 3. Now this t has power 2. So 2 will come out and I can write here t to the power 2 minus 1. Similarly, 5, this t has power 1. So 1 will come in the front and I would write t to the power 1 minus 1 plus 6. Now this t has power 0. So 0 will come here. So what is the equation of velocity? What we got here? Tell me.
Hmm. 6t plus 5 plus, well, I guess that's 6 by t.
0. Anything multiplied by 0 is 0.
Oh, yeah, that's 0.
So the equation is going to be 60 plus 5. Now, again, we have the displacement of the particle, which is a function of time, as 3t square plus 5t plus 6. In order to find the velocity from this particular equation, we have to differentiate it. So after differentiating it, we got 60 plus 5. This is what velocity is. This is how instantaneous velocity can be calculated. Next thing here we have is instantaneous acceleration. That is another part. Another important term that we didn't cover yet. Instantaneous acceleration. So instantaneous acceleration is something which is defined as acceleration of the particle or the body at any particular instant. What does it mean? It simply means at any point of time throughout the journey, if I assume that the particle is moving with some random motion, so it is going to have instantaneous acceleration, and that instantaneous acceleration is something which is represented by I instantaneous. It is equals to dv by dt. What it actually represented? It is representing that instantaneous acceleration is nothing but rate of change of velocity. Just like we defined instantaneous velocity, we are also going to define instantaneous acceleration. So instantaneous velocity is rate of change of displacement. So instantaneous acceleration is going to be rate of change of velocity. I can sense this that this is something which you're going to learning for the very first time. So sometimes things doesn't make sense. But as soon as we cover so many questions upon the same topic, these things will automatically start making sense.
Yeah.
So how we are going to calculate it? We are going to calculate it by using the same relation. So by what time you are going to cover that derivative part?
Probably by like maybe middle of September. But the thing is, this is all. Is this honors physics curriculum or AP physics? Because I'm taking honors.
This is something which is there in every course. So
Oh, really? Okay.
don't
Because
get
because you
confused.
know how for honors you only need to know algebra 2, right? So I'm not sure if derivatives will be taught in the honors physics class.
Yeah, that will be completely fine if it is not there also. But
Yeah. Oh,
The
yeah. Sorry,
equation,
that's extra information.
the equations will remains as it is the same they are. So
All
it
right.
won't going to change. Yeah.
Sure.
So when we are going to end the session, just make sure you share your screen and show me the textbook. Like you
One
have
second.
that,
Yeah.
uh, you have the soft copy, na? Which you can't share.
Yeah.
So
Okay.
just show me the textbook so that we can align all the topics with that only.
Mm-hmm.
So remember these equations.
Okay.
These equations which we saw here, v minus u is equals to 80, x minus x naught is going to be ut plus half 80 square, and v square minus u square is going to be 2a x minus x naught. These are going to be the enough to solve every problem related to this particular concept, motion in one dimension, or you can say rectilinear or translatory motion. Let us do a
Okay.
problem. It will help you to reconnect or collect all the things. So suppose there was a body traveling initially with 5 meters per second of velocity. Also, the acceleration of the body is 2 meters per second square. Question is find first part, the final velocity after 7 seconds. Second point, how much distance will it cover at the end of 10 seconds? This is what the question says. So how we are supposed to solve it? Let us do. And the next question is something which you are going to do.
Okay.
So let us understand it. So whenever you are solving any problem in physics, just follow the basic steps. The first step is to write whatever is given in the question. Exactly, same to same. So here it is saying the body was initially traveling with 5 meters per second of velocity. So here we have initial velocity of the body. So initial velocity is supposed to be 5 meters per second. And it
Mm-hmm.
also says that the acceleration is something which is 2 meters per second. So I can write it as 2 meters per second square. First part, the question says what is the final velocity? So final velocity we have to find, that is v. And after what time? After 7 seconds. So now just think and tell me from these equations, these three equations, which equation should I use in order to find v? So here we have v in two different equations, first and third. Now just think it
Probably first one.
properly. Yeah. So by using first equation, we can use and find velocity.
Because the reason why you can't use the third one is because we don't have the displacement.
Exactly. That's
Okay.
nice. So using first equation of motion, which is nothing but v minus u is equals to at, or we can write v is equals to at plus u. We substitute the values. Acceleration is something which is 2, time is something which is given as 7, and initial speed is something which is 5. So final velocity is going to be 14 plus 5, that is 19 meters per second. So this is how we are going to solve for the first part.
Yeah.
That's pretty good. Second part. How much distance will it cover at the end of 10 seconds? So now the time changes to 10 seconds and we have to find the distance. Or I would say the particle must be asking about, the question must be asking about the displacement of the body. It is going to be x minus x naught. So now again, think of the same equations and tell me which equation should I use in order to find out the displacement. Considering whatever you have given.
Mm, 2.
Correct. So we're going to use the second equation in order to find out the answer. So I will write using second equation of motion, that is x minus x naught is going to be u t plus half a t square. So u is something which is initial velocity, which is 5, time 10 seconds, plus half a. A is something which is 2 and time is something which is 10. So we have to put the square of 10. So it is going to be 50 plus 100. That is 150 meters. So I can say that the displacement of the distance covered is during this 10 second is going to be 150 meters. So this is how we are supposed to solve the problems using these equations of motion.
Okay.
Let me give you one more problem and you are going to solve it and tell me the answer.
Yeah.
So the question says a particle was initially at rest. Particle was initially at rest, started accelerating at a constant rate, of 4 meters per second square. So the question says, what is the displacement of the particle after the end of 12 seconds? Now, try it out and let me know how we can solve it. First of all, tell me which equation is supposed to be used to solve this problem.
Mm, so acceleration, then you want displacement, time. Is it 2?
What to?
The x minus x, x dash
No, no, no. Just
equal.
think wisely once again.
Oh, the particles at rest. So is it number 3?
No, no, no. Just let's see. So first of all, we need to understand what is this rest means. So particle was initially at rest. It means that initial velocity is going to be 0 meters per second.
Yeah.
And then it started accelerating at a constant rate. So it's given that acceleration is going to be 4 meters per second square. Then the question says, what is the displacement of the particle after the end of 12 seconds? So time is given as 12 seconds. Now, based upon the given information, and the question is something that we have to find is x minus x naught. So, based upon this given information, just tell me which equation should I use to find x minus x naught.
Equation x minus x naught equals ut plus half at squared.
Yes, so using second equation of motion, I can write x minus x naught is going to be ut plus half at square. So u is something which is 0
Mm,
multiplied by 12 is going to be 0. Half acceleration is something which is 4. Time is something which is 12. So we have to write square of 12. When we solve it, we get 0 plus twice of what is the square of 12? 144.
144.
So x minus x naught is going to be 288 meters. 288 meters. This is what the displacement of the particle is after the end of 12 seconds. That is what we
Yeah.
need to understand here. How we are going to apply the equations of motion. That is what it is required. All right. So let's do one more problem. Try it
Mm,
out and see whether you are able to solve it or not. The question third. So the question says a particle moving with 10 meters per second initially and accelerating at a constant rate. So it must be accelerating or moving at a constant rate. After 15 seconds, its velocity changes to 40 meters per second. Question is find displacement during that interval. So what is going to be the displacement during that 15 seconds of time? This is what we are supposed to find. Now just think and tell me which equation should we use and what are the things which are given here. Figure it
um,
out. Tell me.
but we're not given acceleration. It just
Yeah, it's
tells us
not given. Yeah, it's not given. But we can find it somehow. Think of it.
is it v squared minus u squared equals 2a times x minus x naught.
But again, think, see how we are supposed to solve such problems. First of all, we have to write what it is given. Without understanding what it is given, we are not supposed to find what exactly need to be found. So initially it says the velocity is 10 meters per second. So u is supposed to be 10 meters per second. It is accelerating at a constant rate, but the acceleration is not given. But after 15 seconds, so time is something which is 15 seconds, velocity changes to 40 meters per second. Question says what is going to be x minus x naught. Now, based upon the given information, if we move to the equations of motion, we know that there are three equations of motion. And in order to find out x minus x naught, like this or this, so we have two equations. And in both the equations, one thing is common that we need to have acceleration. Without acceleration, we cannot find this acceleration, displacement. So how can we find this acceleration first? And then whatever acceleration we are going to find out, we need to substitute either in second equation or third equation, we'll get our answer. The acceleration is something which can be easily found out using first equation. So here we are going to
Yes.
use two equations simultaneously in order to have the answer. So see how we're going to find out. First, firstly, we'll find acceleration using first equation of motion because we have all the three things which is required to find out acceleration. So what acceleration is going to be? Tell me.
Um, v minus 10 equal 40 minus 10 equals 30. 2,
Three.
3. What?
Okay, sorry. Yeah, it's going to be two.
Okay.
For 10 seconds, it is going to be 3, but after it is 15 seconds, so it is going to be 2. So the solution is going to be 2 meters per second square. Now just apply the second equation or third equation, whichever you feels like, and tell me the value of x minus x naught.
Okay. Is it 375?
Correct. So this is how
Okay.
we are supposed to find out displacements and whatever physical quantity which is being asked in the question. So remember the process. First, you need to figure it out that what is given in the question. Second, you need to understand that what you actually have to find. So just figure it out that which equation of motion out of the given three equations you use, and ultimately you can solve for the equation of the variable and you can have your answer. So it is something which requires a lot of practice, because sometimes we get confused that which equation should be used. But once you practice, you will automatically be able to understand that how we are supposed to solve it.